Then we factor out this h on the left side. So we have the h times 1 over the tangent of the 68 degrees plus 1 over the tangent of the 76 degrees equal to 1.2. Then we divide this guy. We get h equal to 1.2 divided by 1 over tangent 68 degrees and plus 1 over tangent 76 degrees. So some guys have trouble with inputting, with punching all those numbers in the calculator. Now let me show you how to punch all these numbers in the calculator to find the answer. So you may first punch in the 1.2, then divide, then left parenthesis. So here the denominator has more than one term. You must use a pair of the parentheses to enclose the whole thing. Otherwise, you cannot get the right answer. Okay, so you have the then 1 divided by tangent 68 degrees and plus 1 divided by tangent 76 degrees, and then right parenthesis, and then press enter, you get answer. And some guy asked question about the significant digits. Last time we talked about the significant digits for the fraction number, right? For the number with the fraction part. If you have number without fraction part, just an integer, say you have the 12,000, then the number of the digits in this integer is just the number of the significant digits. So for this one, it has the 4 significant digit. Right? So if you have the, say, 16, then this guy has the 2 significant digits. Now, let's open a new chapter for this Math 100 or Math 140. And we talk about the chapter 6. So it's about trigonometric identities and conditional equations. And let's first begin with the section 6.1. We talk about the basic identities. So let's first explain what the identity is. An identity is just an equation that is satisfied by every number for which the both sides are well defined. For example, x minus 1 equal to x squared minus 1 divided by x plus 1. This is an identity because this is equation and is satisfied for every number for which the both sides are well defined. So when the x is not equal to -1, right, then the both sides are well defined. Then for every number not equal to the -1, this equation holds, right? Then every number not equal to -1 satisfies this equation. Then this equation is an identity. So actually, we have learned some identities in the chapter 5. First, let's list the identities from the definitions, right? So actually, we begin with the point of the intersection of the terminal side with the unit circle. Let me use the x and y for this intersection point of the terminal side with the unit circle, right? And we know, and suppose the angle is alpha, right? So we know the sine alpha is just equal to y, cosine alpha is equal to x. And we have the tangent alpha equal to y over x, and cotangent alpha is equal to x over y. Then we have the secant alpha is equal to 1 over x, and the cosecant alpha is equal to 1 over y. Okay. So from these definitions, then we immediately get identities from the definitions. That is the tangent alpha is equal to sine alpha over the cosine alpha, and cotangent alpha is equal to cosine alpha over the sine alpha, and secant alpha is equal to 1 over the cosine alpha. Cosecant alpha is equal to 1 over sine alpha. And from these identities, we may immediately derive some reciprocal identities. So those are the identities from the definitions. And then we have the reciprocal identities. So first, we have the sine alpha equal to 1 over the cosecant alpha, right? Cosecant alpha is equal to 1 over the sine alpha. So from this identity, we get the sine alpha is equal to 1 over the cosecant alpha. And then cosine alpha is equal to 1 over secant alpha. And then tangent alpha, which is equal to the reciprocal of the cotangent alpha. Okay, and we also need the cosecant alpha is equal to 1 over the sine alpha, and secant alpha is equal to 1 over cosine alpha, and then cotangent alpha is equal to 1 over tangent alpha.